So today's lesson 3.4, we're going to be solving equations that are in the form ax plus b equals c. So the big idea is an equation of the form ax plus b equals c can be solved in two major steps. So when we were in middle school, we simply called these two-step equations. Now in 3.3, we dabbled with the fact that there is more than one way to go about this, but there's kind of one set way that works all the time. That's probably the best practice, and that's really what we're going to focus on today. So when you see ax plus b equals c, there's going to be numbers in almost all of these spots with the a, the b, and the c. We will have that x, and our final goal is to solve for x. When you solve for a variable, it simply means get it by itself. It doesn't always mean you know what number or numerical value it is, but it's going to say x equals everything else, and then you have solved for that variable. So no vocabulary words today, simply can we solve these equations? Okay, so this should be pretty simple. So we're going to solve and we're going to check them. So checking, we just take our answer, we plug it back into the original, and we make sure that it actually works and it makes sense. So here we go. So when we have a two-step equation, usually we're going to add or subtract first. Again, our final goal is to get that y by itself. When I say by itself, you've got this equal sign, there's a left and a right side. All we want on the left side of that equal sign is y. So it says y equals everything else. And then since everything else in this problem is a number or a numerical value, y is going to actually equal just one single numerical value if we simplify everything. Okay, if there was other variables, then y could equal an algebraic expression on the other side, and that's okay too. But for these, we're going to get an actual number, and then we're going to plug it back in and check. So first step, usually we leave whatever is being multiplied or divided with our variable for last. Talked yesterday that you don't have to, but best practice is usually to get rid of whatever's being added or subtracted when you have one of these two-step equations. So to get rid of it, we have to get it to 0. So we're going to count this like it's a negative 432. So we need a positive 432 to get this to 0, and we always have to balance it. Okay, both sides of the equation. So these simply cancel out, and we're going to have 73y equals, we're going to add those together. That's 1533. And at that point, right now it says 73 times something equals 1533. So if you're going to work this in your calculator, you would divide to work backwards, and that's what we're going to do here. Now the reason that this works is because 73 divided by 73 is 1, or 73 over 73 is 1. So we're going to have a 1y. And then on this side, we're actually going to do the math. We're going to simplify this, and we get 21. All right, so we think the answer is 21. So in order to check this now, we're going to go back to the original. So I always want you to actually write the word check. Be really organized with your work. And the first line should actually be the problem rewritten. So here we go. We think it's 21. If we plug 21 in, both sides of this equation should be equal if 21 is correct. So first step is to actually substitute 21 in for y. So I literally rewrite everything except for the y becomes a 21. Multiply this. Now we're just going to simplify the left side, simplify the right side. The right side is already simplified, so we're not doing anything with it. It's going to stay 1,101. We're going to simplify the left side and see if it comes out equal to that. So when I multiply here, I get 1533. And this should be a 432. All right, and you'll notice when we work backwards through this problem and then back forwards with our answer in the check, we're going to have a lot of similar numbers as we move through this. So here's the 1533 again. Now we're going to subtract here. Sure enough, we get 1101. Our check works, which means y equals 21 is the correct answer. All right, so we saw subtraction. We added. So if we look at this one, first of all, it's kind of changed. X is now on the right side. If it really bothers you, you can rewrite this. If you want x on this side, if you like the way that looks better, then rewrite it because these say the same thing. It's saying that this equals this. So is this. Okay, so if you need to rewrite it, if you like x on the left side, then that's fine. All right, but I'm going to work with it on the right side just so we can see. So I want to get x completely by itself on the right side of the equation now. I save multiplication or division for last, so the plus 42 needs to go. So anytime we struggle with what do we do, add or subtract, just think about getting to 0. So it's a positive 42. I'm going to minus 42. One other mistake that students make is they know that they have to write minus 42 twice. They're not just going to write it once. They're going to write it twice, but where does it go? So first of all, you can only do it once on the right side of the equation and once on the left. And if there was multiple things over here, you would write it underneath something that it can actually simplify with. So if we had something like x squared or a y or even just an x, I wouldn't write minus 42 under it because you can't actually combine it with it. But I can combine a 42 with a 126. Those are like terms because they don't have variables. So that's where it lines up. So once on the right, once on the left, underneath whatever it's going to simplify with. So we cancel over here, leaving me 6x. And 126 minus 42 is 84. Again, it says 6 times x. If I divide, I can reverse this. So 6 divided by 6 is a 1x. I've now gotten it by itself. And 84 divided by 6 is 14. This is a good answer. 14 equals x. Again, if you prefer, if you're just so used to it that it bothers you that you want x on the left side, you can certainly flip it and you haven't changed anything. Now, let's do the check. Rewrite the original. I know a lot of you are going to want to just jump right in, but rewrite the original. So starting with the variables, let's substitute it. So rewrite everything except the variables. So x is going to become what we think x equals. The left side is simplified, so we're not doing anything with it. Let's simplify the right side. Always follow your order of operations. So 6 times 14 is 84. Again, similar number to what we had up there. And then when I add those together, I get 126 equals 126. So if these two sides did not come out equal, first check your math here, make sure you didn't make a mistake. And if you didn't make a mistake here, that means your answer is wrong and you actually made a mistake with your algebra and you need to go back and fix it. All right, last one of these, just basic examples. You'll see this one has a fraction. So how do I get rid of a fraction? So look at your left side and right side. D is on the left side. The only variable we're dealing with here is on the left side. So our final goal is to have that D by itself. So no numbers on the left side, just a D. This is being multiplied. It's 3/5 times D. Sometimes you'll see, if this was a 1, you'd see the D on top of the 5, and you could read that as D divided by 5. And then to get rid of it, you'd multiply. But we'll deal with the fraction in just a minute. First thing we want to do is we want to get rid of this 7. Now, you would say, well, it's being added, so I would subtract it. True to a point. But if this was a minus here, it would actually be making this 3/5 negative, and it wouldn't affect the 7. So even if this said minus, you wouldn't add it, because if you added 7, even if this said minus, you'd have 7 plus 7. You'd get 14. You can't cancel it. So since this is a positive 7, you actually want to look at the sign that's in front of it. Since this is a positive 7, I'm going to minus 7 on both sides of my equation. And if it was a negative 7, even if it said plus right here, if it was negative 7, you'd have to add 7 to get it to 0. So you're looking at the sign of this number if it's just sitting out front. All right, so they're going to cancel, leaving me 3/5 D and negative 12. Now everybody freaks out, right? It's a fraction. So our goal, if you look at all of these ones over here, is to get x by itself by dividing when I see multiplication. Well, that's what this is. So technically, I could divide by 3/5, make a bigger fraction with a fraction underneath of it. That's fine, but when we divide by a fraction, we actually multiply by the reciprocal. We KFC, right? So we would write that, but then we would end up going back and changing it to multiplication anyway. So let's not make our lives more difficult. Let's not write division and then multiplication, even though it's not wrong. Let's be efficient. So we divided by 6 over here because 6 over 6 was 1. So I want to create a 1D. I want this to be a 1. So when I have a fraction, what do I do to get 1? Well, I multiply by the reciprocal. We just studied that. So if I multiply 3/5 by the reciprocal 5/3, I would end up with 15 over 15, which is a 1D, which is what I want. So if you've got a fraction that's being multiplied times a variable and you want to clear it out, just multiply by the reciprocal. So both sides have to be multiplied by the same thing. So be careful. I multiplied by 5/3. That's what I'm multiplying over here. So these cancel, leaving me just D. And now over here, think about it like this. Okay, so when I multiply here, this is over 1. I'm going to get negative 60 over 3, which can simplify. Just divide. Negative 60 divided by 3 is negative 20. And if you use the little shortcuts up here, you could simplify early, get straight to the answer. So I see the 12 and the 3. So the 12 can actually simplify to a 4 and a 1, because 12 and 3 could simplify. And then when you multiply negative 4 times 5, you'd get right to your final answer of negative 20. So feel free to simplify early if you see it. Let's quickly run the check. So rewrite the original. First step, plug in. So D becomes negative 20. You again can do this in your calculator. Use the fraction key, 3/5 times negative 20. Get you the answer. You could also do 3 divided by 5 and get the decimal version, 0.6, times it by negative 20. Okay, and when I do that multiplication, I'm going to get negative 12. And 7 plus negative 12 is negative 5. And it works. Okay, so that's running through the basics of how do we just solve a two-step equation. So let's flip it over. Let's now look at problems where we're going to have to create a two-step equation and then solve it. So example number 2, here we go. When Val works at the zoo, she earns $10.80 per hour. She's also paid $8 for her meals and $3 for transportation. Okay, so she's paid 2 extras that are constants. And then the $10.80 changes based on how many hours she works, but every hour is $10.80. So anytime it's per hour and you're going to make a different amount based on how many hours, there's our variable. We're going to have to do $10.80 times the hours. So I always want you to define your variable now. So defining your variable means just stating what it represents. So even if it's a letter and you say, well, it just makes sense, it's H, it's hours, I still want you to state it. So the variable we're going to use is H, and H represents the number of hours worked. Okay. So now we want to write an equation. So she's going to get paid $10.80 times H, like right here. So depending on how many hours she works, you're going to multiply that by $10.80, plus she gets paid $8 for meals, plus she gets paid $3 for transportation every single day. Last Saturday, she received $83.90 in total. So she worked a certain amount of hours and got paid $10.80. They gave her $8 for her meals and $3 for transportation, and that came out to $83.90. Let's simplify this. On the left side, this has a variable. Okay, this 8 and the 3 are not affected by the number of hours that she worked. But instead of writing it as 2 separate payments, basically she gets $11, and that covers her meals and transportation. But she's also got $10.80 times however long she worked, and that's going to come out to the $83.90. So there's our nice cookie cutter 2-step equation. We want to get H by itself. We're going to subtract 11. So I have $10.80 left over. 10.80H. And then when I subtract over here, I've got 72.90. So if you had to explain what you actually did here, is you took out the $11 for meals and transportation from the total amount that she made. So she made $83.90. If you take the $11 off, you're left with how much she got paid for her hours. So she was paid $72.90 for her hours. Each hour was $10.80. So we want to figure out, let's go to blue. We want to figure out how much she gets paid, or how many hours she got paid $10.80 for. Because that's our question. How many hours did she work? We're going to solve for H. Okay, so these go away because we've divided. You get 1H, and we're going to divide right here, and we have 6.75. Word problem should be answered in a sentence. So Val worked 6.75 hours. You could go back and check it, do 6.75 times 1080. That's how much she should have got paid for her hours, and then add the 8 and 3 or add the 11, and you should get the 83.90. All right, last one, example number 3. Mrs. Smith bought gas for $2.39 a gallon and a drink for $1.50. Her total bill was $31, so total is usually going to say equals your total. Her total bill was $31.15 before sales tax. So we don't have to figure any tax in. That's why they say that. So we don't have to deal with any of that extra stuff. So that's just her total bill. How many gallons of gas did she buy? So first of all, when they ask you a question like this, and you're trying to solve for how many gallons of gas, then that's probably what your variable represents. And if you go back, we know how much she paid per gallon. We know she paid a certain amount for a drink, but we don't know how many gallons she bought. So we're going to use G as our variable. That's what we're solving for. And that's our gallons of gas. Okay, so let's write an equation now. Now it's almost always going to say equals your total. So let's write that down. So she paid a whole bunch for gas, for her drink, and all together when we add that up, so there's going to be a plus, it's $31.15. So we know she paid $2.39 per gallon. We don't know how many gallons, so we'd be multiplying $2.39 times however many gallons of gas she bought. Because if she bought 2 gallons, we'd times this by 2. So $2.39 G plus, so this would represent the money she spent on gas, but she also spent $1.50 on the drink. So if we added the amount on gas, the amount on the drink together, we get the total. So it makes sense. Okay, so now that we've got it set up, we can just run the numbers. We want to get G by itself, so it says G equals, so gallons equal. So first thing we're going to do is get rid of the adding and subtracting. So we're going to get rid of the 150. It says plus, so we're going to minus. Basically, we're taking the total amount that she spent, and we're going to get rid of the drink. And then we're going to have how much money she just spent on gas. So when I subtract here, it's $29.65. We know she spent $2.39 for each gallon, and now we know how much money she spent just on gas, $29.65. So now I want to know how many gallons did she get. So how many times does $2.39 go into $29.65? Now, if you do this in your calculator, it's not going to be a perfect number, and most of the time in the real world, you're not going to get a perfect number. So $29.65 divided by $2.39. Looks like this. Okay, so G equals, I'm going to write it all the way out for now. Now, in the real world, when you get nasty decimals like this, you also don't express them in regular conversation. If you're doing high calculations for a company and you really want to be very precise on like how much money you're spending or how many gallons you're actually selling, then you need to leave all these decimals because you do change the number when you shorten it. But to give just an answer here about how many gallons of gas did she buy, we're going to shorten this up. It doesn't say specifically how to round it, so we're going to be reasonable here. 12.40, so pretty much everything after this doesn't really matter because of this 0. It's just these numbers are just super small. So the 12.4 is significant. I would call this a significant spot. 12.4 is a lot different than just 12. 12 gallons and 12.4. That's almost a half a gallon. But 12.405 is not that different from 12.4. There's not a big difference between those two numbers. Okay, so let's just go with what's significant. So I'm going to put G. I'm going to put a little squiggle here. And what that means is I've rounded. This is not saying it's exactly equal to 12.4, but it's approximately 12.4. If I write equals, I'm telling you it's exactly 12.4, which obviously it's not. So let's write our full sentence. Mrs. Smith bought approximately, and I have to say that because I rounded, 12.4 gallons of gas.